First of all, I am so happy that you made it to this stage. Now, what if? I like what if. What if the highest degree on top is greater than the highest degree on the bottom? So look at the function. The highest degree on top is 3. What about the bottom? The highest degree is 2. So what happened? How does that affect the horizontal asymptote? So in this case, when the highest degree on top is greater than the highest degree on the bottom, then you have no horizontal asymptote. Yes, you're right. No horizontal asymptote. In fact, there is a slang asymptote. So what is slang asymptote? Slang asymptote is not horizontal. It's like a straight line, like a linear function that has some slope. So an asymptote, not horizontal, not vertical, is like a linear function that has some slope. Okay, before we go into that, so let's quickly point out what the vertical asymptote is. So factor the denominator. You can see that when x equals to -3 and positive 2, the bottom is messed up due to the 0. So we have to point out that x equals to -3 and x equals to 2. They are vertical asymptote. Why? Because they are non-removable discontinuity. They are non-removable discontinuities. All right. Now, the next step is how I said no horizontal asymptote. You can see in the picture, but you can see it. It's not a mathematical explanation. You can see it. Write this down. You can see it. It is obvious, or you can see it. They are not reasons. Okay. So how do you show it mathematically? Here is how. So let's write the limit one more time. So I'm not going to be lazy. I will just copy it one more time, and then x squared plus x minus 6. So this time you have to divide the top and bottom by what? You have to divide the top and bottom by x raised to the what? X. Let's use a different color. You have to divide the top and bottom by x raised to the highest degree. Sorry, not the top. You have to divide each term by x raised to the highest degree in the denominator, which is a 2, right? I use 2 because the highest degree in the denominator is 2. I don't care what you have in the numerator. So even though you have x raised to 1000 degree in the numerator, I don't really care. I only follow what's in the denominator. All right. So moving on. Can I just squeeze that? Let's try. So we have limit as x approaches to infinity, and then we have x to the third divided by x squared, square, x squared, 6 squared. What did I do? X squared. And then you have limit, simplify the power. The top you have an x left, the bottom you have a 1 plus x divide 1 divided by x minus 6 divided by x squared. Once x goes to infinity, you have infinity divided by 1 plus 0 minus 0. So infinity divided by 1 is equals to infinity. It's not a number. So in this case, you can box this. You can say that the limit does not exist, and you can say that there is no horizontal asymptote. So there is no horizontal asymptote. But I said that there is a slang asymptote, right? How do you find the slang asymptote? So here is how. Let me do the math over there. Let's use a different color, shall we? Let's use orange. So to find the slang asymptote, do you see that there is a word called long division required? So do you still remember long division? I hope you do. So for long division, you have to take the numerator divided by the denominator. Okay, so you have to do x to the third, and then this is a x squared minus plus x minus 6, and then look at the numerator, or the dividend. You only have the third power. There is no second power, no first power, no constant. To make this look nice and easy to read, you can use magic zeros like this. You can add 0x squared, 0x, and 0. You can add those terms back just using a 0 because that doesn't change anything, right? And then the first term, I'm going to use an x because x times x squared is equals to x to the third. That is the only possible answer, because if you use like 2x or 5x squared, whatever that is, you are not able to get rid of the x to the third. And then x times x, x squared, x times 6, negative 6x. And then here, I want you to write a minus because you are performing a subtraction. X to the third minus itself, gone. 0 minus x, that is negative x squared. 0 minus 6, that will be a 0 plus 6, so that is a 6x, and then you drag the 0 down. All right, when you perform a new division, the first terms must be cancelled, must be gone, eliminated after the subtraction. This is a must. There is no other choice. Now, what's the next term? The next term I would do a minus 1 times x squared minus x squared minus 1 times x minus 1 times 6, and then you are performing a subtraction, all right? Negative 1 minus 1, gone, right? Negative 6 minus 1, so that will be a negative 6 plus 1, 7x, 0 minus 6, that will be equals to negative 6. Without, trust me, without the subtraction symbol and the parenthesis, people will just do, okay, 0, 6, okay, that will be a 6, which is wrong. Now, and then what's the slang asymptote? Here is the slang asymptote. The slang asymptote is x minus 1, is the quotient, so this is quotient. That is the quotient. So what is that equal to? So whatever is given, the function is equals to the quotient plus the remainder divided by the divisor. Quotient plus remainder divided by divisor. How about this? Let's try something else. How about 7 divided by 3? How do you do this? Still remember? So you have a 2. 2 times 3 is equals to 6. This is a 1, right? So 7 divided by 3 is equals to the quotient plus the remainder divided by the divisor. Quotient plus remainder divided by divisor. Okay. Alright then. Then since this is a x plus 1, then here is what we say. So since this is a x plus 1, so this x plus 1 tells me that y equals to x minus, what did I say, plus? X minus 1 is a slang asymptote. Alright, so as x goes to infinity, right? So as x goes to infinity, we took what is right over here. So as x goes to infinity, y goes to infinity. So that's why you look at the picture right over here. As x goes to infinity, y goes to infinity. As x goes up, y goes up, right? So what happens when x approaches to negative infinity? So based on this piece, y goes to negative infinity as well, right? So y goes to negative infinity as well. If you want to look at the math, so here is the math. So what you are taking is this piece. So you will be taking this piece. So we are going to copy and then paste. We are taking this piece and then we will be change this to negative infinity. So negative infinity. So this will be a negative infinity and then a 1 plus a 0, because negative 0 and positive 0 makes no change. You can say minus 0 if you like, and then minus a 0. So this will be a negative infinity divided by 1. So that's how you get a negative infinity. All right. Regarding the left side and right side of the vertical asymptote, I already did 2 examples in the previous videos. You should go watch that. Okay, so that is the end of this example. I hope you got everything right now. If you think this is helpful, you like the way I teach, give me a thumbs up, share the video for me, click the subscribe if you're on your way out. I will catch you all in the next one. Signing out.